So if I have 2 times c, what do I write? What's the answer? -8 and 10, right? You're just multiplying. So it's 2 times -4. I'll just show that step, comma, 2 times 5. It is easy. So you get -8, comma 10. Right? We just made that vector twice as long. Thanks. Yep. Maya. If I add a and b, right, I'm going to do -6 plus 1, comma, 2 plus 7. Right? So writing a formula for that is just silly, right? A1 plus B, A2, B1 plus B2. So I don't think you need a formula personally. So you get -5, comma 9. Like that. So there's just a whole variety of different ones you could do. 1/2 times A, subtract B. Still not that hard, right? So I don't really want to do any more of these because I think they're easy. Are you guys good with that? Yeah? Okay. So then we get into some weird stuff. So a vector with a magnitude of 1 is called a unit vector. And we have a formula for a unit vector. That formula is, so unit vector, magnitude of 1, is whatever the vector is. We got to get, what does that mean down here? Right, we do the magnitude, right? So just to remind you what magnitude is, so like the vector stuff is easy, right? The math is easy. It's just remembering what to do when. That's the hard part in my estimation. So if I forget those formulas, I'm going to write the formula somewhere so I don't forget. So we do square root of a squared plus b squared to get that, okay? So if we do this one right here, we're going to get magnitude of v first. And we're going to do square root of -5 squared plus 12 squared. So we get 25 and 144, which is 169. And square root of 169 is 13. So if I then just plug that into, into the formula up top here, right? It's just 1 over 13 right there. So I'm going to multiply 1 over 13 times the -5. So I have 1 over 13 times -5, comma, right? It's going to be like our new component form. And then I multiply 1 over 13 times 12. So I get -5 over 13, comma, 12 over 13. Okay, another acceptable, although I don't think you're hardly ever going to use this, you could write it, I'll just write it on 8, so you could cross 8 out. You could write it like this, 1 over 13, because I usually will want you to multiply it through. But that's the same answer, right? I just didn't distribute that 1 over 13 into the parenthesis, because sometimes I didn't see one where we had to leave it out in front like that. But so if I look at 11, what do I have to do first? What's that called? Component form, right? So that's why I like writing these little formulas down, because I forget what to do, right? And what is that component form formula? What do I subtract? X2 minus X1, comma, Y2, good, minus Y1. And then I get into component form. So if we had this, just to remind you of how this all works, right? If I were to graph this, it would not originate from the origin. When I put it in component form, I'm moving it back so the terminal side is on, right? That terminal point is at the origin. That's what this does, okay? Just so you can actually understand what the hell's going on. So we have 6 minus 0, comma, -1 minus -7, so -1 plus 7. And then we get 6 comma 6. So we're just adding another layer of work to the problem by giving you 2 ordered pairs, right? So then I have to do what? So I'm doing square root of 6 squared plus 6 squared. And I get square root of 72. And then how can I break apart square root of 72? Biggest factor of 72. 36 and 2. So square root of 36, square root of 2. Only people that make mistakes on this is you just get lazy and you try to do this step in your head and then you make a stupid mistake. So if you write square root of 36 and square root of 2, you're going to write your answer as 6 root 2 because you can see which one you can square root and which one you cannot. Because some people will screw it up by writing 2 root 6 right there instead of 6 root 2. Because you try to do it in your head and you just get all spastic and you do something stupid. So don't do that. Okay? So now we're going to multiply that into our component form, right? Like we did up here. So we have, I'm going to write it over here, I guess. 6 root 2 times 6, comma. Oh no, it's 1 over 6 root 2, right? I was just about to make a mistake, right? Because I need the 1 over v. So if I have 1 over 6 root 2, erase. First thing I want to do, just to make it easier, right? Otherwise I have to rationalize multiple times. What do I do to rationalize here? Root 2 over root 2, yeah? So you get root 2 over 12, good. So that equals root 2 over 12. So it's way easier to do it first, rationalize, and then multiply it than the other way around. So we're going to continue our work over here. So we have root 12, root 2 over 12 rather, times what? Times 6, comma, root 2 over 12 times 6. So what do I get? Root 2 over 2. So you get root 2 over 2, comma, root 2 over 2. That is in component form. Okay? So it's a whole lot of legwork to get there, but, you know, it's not that bad. Again, it's just figuring out what to do when, I think, is the hardest part. So you just got to bear with me for this. Like, I'm asking myself the question why. I got to watch some video that explains to me why the hell they do this because I find it kind of annoying. But there is worthwhile math once we get to this page. But we got to lay some groundwork up here. And I honestly don't know the why, so I'm going to figure it out so I can tell you because it irritates me. Okay, so notice over here, the x-axis now is this I, right? And the y-axis now has a j. So we're going to rewrite it. It's called a linear combination of vectors I and j. So vector I, vector j. Okay? So to do that, you're going to write this ordered pair like this in component form. The steps are what irritate me about this the most. I'm just going to write them down and then you can see what happens. I listened to Gina's explanation again this morning and it just made me mad. If you've been there listening to Gina, I understand. Like her explanation of why wasn't good enough, basically. So now all we're doing on this next step is factoring out the a out of that first component form. So we get 1 comma 0. And then what is 1 comma 0? Up here, it's I. Okay? So like the whole legwork on this seems annoying. So b, and then it's 0 comma 1, and 0 comma 1 is j. Right? So what we end up with is v equals ai plus B, and then the J. So the answer to number 1 makes you wonder why we did all that work, right? It's just that.
We really only need the last one.
You really only need the last one, yes. That's why I got annoyed too. I'm like, really? Why'd we do all that stuff above? Like, so what do I need to do on number 3? We're not going to do it. What do I need to do though? Get it in what kind of form? Component form, right? So I just subtract the x's, subtract the y's, then it's in component form, and then I write I and j after the number, and we're done. Okay. So now we're going to talk about a unit vector. So the terminal point lies on the old unit circle. So we can write it given the unit circle like this. So what is cosine x or y? Right? So cosine theta minus sine theta. And then if we write that as a linear combination, so I would write linear combination has I and j just so I can remember that. Because if I ask you to write it as a linear combination, you need to know that it has to have the I and the j. Because that's an easy thing to forget, right? Because it doesn't tell you that you're going to have that. But if I write it as a linear combination, you should technically be able to write it because it's not that hard. I comes first, then j. So then, if we think about this, every vector is a product of its magnitude and its corresponding unit vector. So we can write it in 2 different ways, except I'm only going to write it in the one way. So we're going to have the magnitude inside of here, right? So is the I'm just going to write it. We'll do problems. It'll make more sense once we do it. Because you just look at that and you're like, thanks. That's not helpful. At least that's how I think about it. And then if I write it as a linear combination, all I have to do is take this, write it again down here, and then all I'm going to do is add my I and add my j at the end, and then it's a linear combination. Okay? Now we get to problems that are actually a little more worthwhile. So you want to think, I'll challenge some of you students that get this really well, right? So we're thinking unit circle now. And I know that if I'm at 30 or I'm at 60, right, my options for the side lengths are either 1/2 or root 3 over 2. So let's just remind ourselves what root 3 over 2 is, because I forget. Yep. So root 3 over 2 is 0.8, let's just say 0.9. So root 3 over 2 equals 0.9. What's 1/2 equal? 0.5. So which, if I'm thinking about root 3 over 2 and 1/2 as side lengths, what's a short side length? What's a long side length? Short side length is 1/2. So if I'm thinking about 60 degrees right here, that means my triangle is like that. Which is a short side, x or y? So what's x? 1/2, right? So what I'm trying to encourage you to do is think about the unit circle, and you know the unit circle already, right? So if I give you 90, what's after 90, the next angle over? What do I add to 90? I add 30, so next one's 120. So what's the x value at 120? No? Think. I know, but what I need to think about my signs as well, right?
Oh,
Negative 1/2, right? That's all I'm saying, right? And then the long side is root 3 over 2. So, right, if I draw it, well, let's not keep going. That's enough, right? But I want you to be able to think about that. Like if you're in advanced pre-calc, you don't ever get a unit circle again. You memorize it, you're expected to know it. And because you can think about it, right, and figure it out. So if I draw 30 degrees, what's the 1/2 side, x or y? Y, right? What's the x side? Root 3 over 2. If I draw it like this and I go in the middle, root 2 over 2. They're both root 2 over 2. And then as I go around the unit circle, all that switches are the signs. So there are only 3 possibilities, right? Unless we're talking about x-axis and y-axis and stuff like that. It's either root 3 over 2, 1/2, or it's root 2 over 2, root 2 over 2. And the signs just switch as I go around the unit circle. So that's all it is, right? So now we're going to write our, so we're finding the component form of each vector given the magnitude and direction of the angle. So we're going to write it like this, multiplied in the magnitude, right? We don't have to find the magnitude, they give it to us, so that makes it easier. And then we have cosine of 60, comma, 8 times sine of 60. What's cosine of 60? 0.5, right? So it's 8 times 1/2. So that equals 4. And then I have 8 times root 3 over 2. So what's that equal? 4 root 3. So I'm just trying to encourage you to do that in your head because you can. If you understand it well enough to try to do it in your head, that kind of stuff will help you next year if you take calculus, right? Because the algebra and calculus is really freaking hard. Like so hard. It'll make your head hurt. Okay? So let's do... That's good. Let's do number 10. So we're going to, when I do 10, I'm going to cross off 12 because there's a lot of work that happens. So first thing we got to do is get the magnitude. So magnitude, you should be thinking that square root of a squared plus b squared. So if I square negative 3 root 2, negative 3 times 3 is 9, root 2 times root 2 is 2, 9 times 2 is 18. So I get 18 under there. Square root of 6 times square root of 6 is 6. So I get square root of 24. Break it apart. Don't say it out loud, just break it apart. If you're on the struggle bus, you can look up here. It's probably a phrase I should not use anymore. Can't say anything anymore. Struggle bus, short bus. You can keep going, like not cool. Okay, so that's the magnitude, right? We just figured out the magnitude. Okay, so looking up here, what else did I need? I have the magnitude. What did I need? I need the direction, right? The direction angle. How do I get the direction angle? Oh, tan, inverse tan, good. Right, if I do inverse of sine, cosine, or tan, that's when I get the angle measure. So I'm going to do that over here. We're going to take up 9 space as well. So you can cross out 9 if it makes you feel better. So then I do b over a. So let's have a moment to think because that's fun, right? If I have square root of 6 over square root of 2, I can rewrite it like that. You can have, if you have square root top and bottom, you can divide the number underneath, right? So 6 divided by 2 is 3. What else do I have left of the fraction over here? What's the only thing that's left in the bottom? this right here, right? Because the negatives are going to cancel. So I just have over 3. All right, challenge moment for some of you. At what angle, right? Which quadrant am I in, by the way, right here? Quadrant 3. So what angle in quadrant 3 has root 3 over 3 as a tangent value? 210. Yeah? Okay. That's good, right? I encourage you to think like it, because you have to think a little more and it makes you feel smart. That's always fun. So then we have 210. So this equals 210. Now let's see what happens if we throw that in the calculator, right? I'm just going to do tan of root 3 over 3. Because we kind of skipped a step right there, but it made it easier the way we thought about it. So if I have square root of, make sure your calculator's in degrees if it's not. I get 30 degrees. What? Why does that still make sense? You got to add 180, right? 180 plus 30 is 210. Okay? So that's like, if you do it in your calculator and you don't end up in the right quadrant, right? Sometimes you got to add 360. Sometimes you got to add 180 to get it into the proper quadrant. So all that stuff will happen, right? So 210. Now what do I do? Right? All that legwork just to get to this place right here. Right? So I'm going to plug it in. Well, actually, I'm right here. So at 210, so 210's over here. What's the short side? X or Y? Y. So if I write my ordered pair, I'm going to write negative root 3 over 2, comma, negative 1/2. Right? That's what this point is right there. Because the X is the long side and the Y is the short side, right? So then my formula, I have to multiply the magnitude, which was 2 root 6. So 2 root 6. I'm just going to write it like this so you can see it, right? So the X value is negative 1/2. And the Y value is negative root 3 over 2. Okay. So we're going around in circles, right? Oh, I did swap it. Thank you. I didn't mean to swap it. Your head will start spinning eventually, right? But you can look at your unit circle for all this, right? I'm just encouraging you to think about it. Now, we have to multiply that in. When I multiply the Y value in, what do I get? Because that's the easier one to multiply. So if I multiply this one in, what do I get? Do it in your head. It's not that hard. Negative root 6, yeah? And then when I multiply the first one in, I'm going to do it over to the side here. So I have 2 root 6 times negative root 3 over 2. What cancels right away? The 2's. So then I get negative root 18. Do it in your head. Simplify it. Think. You can do it. Just think. Don't say it out loud. Just think what it is in your head, right? You're breaking apart square root of 18. And I'll show steps for those that need to see it. Did you get it? Oh, I wrote the wrong number there. You got it, but I didn't, right? So negative 3 root 2. Right? It's a long way to go for all that stuff, but that's how you do it. Okay? So 13, all you have to do is get component form first, and then you do all the same crap. Okay? So we're not going to do that. Do you know what I'm talking about? You looked with confused eyes right there. So component form, right? I do second x minus first x and get it in component form, and then do magnitude and figure all that stuff out once I'm in component form. So if you get one that's not on the unit circle, right, you just do second tan of whatever that fraction is and make sure your angle's in the right quadrant. That's the only other additional thing you got to do. Okay, your homework's 1 through 12. Enjoy. And I will display the answers as well.